Good day everyone, welcome back to our discussion on the topic integration. Today we'll be choosing some of the application of integration with focus on area under a curve. Our first question is from WAEC 1996. It states that A. Sketch the curve y equals to as minus s squared minus 12. B. Draw the line of symmetry of the curve. And C. Find the area of the finite region bounded by the curve and the s-axis. Now, finding the solution to our A, the first thing we are going to do is write down our equation, which is y equals to 8s minus s squared minus 12. And to sketch our curve, we are going to be needing 3 points. That is the turning point, the y-intercept, and the s-intercept. Now, the first thing is to look for our turning point, and to do that, we are going to be looking for the y over the s and also for the square y over the s squared to know if it's a maximum or minimum point. This is going to tell us the direction of our curve. Now, differentiating our function y equals to 8s minus s squared minus 12, the y over the s will be equals to 8 minus 2s. And we know that at turning point, the y over the s will be equals to 0. So therefore, 8 minus 2s will be equals to 0, and 2s will be equals to 8. Dividing both sides by 2, s will be equals to 4. Now, the value of y at the turning point, that is, to be substituting s to be equals to 4 into the equation, y will be equals to 8 in bracket 4 minus 4 square minus 12, which should be equals to 32 minus 16 minus 12, which should then be equals to 4. So at the turning point, the value of s is 4 and the value of y is also 4. Next, we need to determine whether it's a maximum or a minimum point. And to do that, we have to find the value of the square y over the s square. And if it is greater than 0, it is minimum, and if it's lesser than 0, it is maximum. Differentiating, the square y over the s square will be equals to minus 2. That's when we differentiate 8 minus 2s. And since it is lesser than 0, it is a maximum point. Now, the other two coordinates we'll be needing are the s-intercept and the y-intercept. Now, at the s-intercept, y is equals to 0. So 8s minus s squared minus 12 will be equals to 0. And solving the quadratic equation using factor method, we are going to be looking for two numbers in which one we multiply them, it is going to give us 12, and when we add them, it's going to give us minus 8. The number are minus 6 and minus 2. So substituting minus 8s to be equals to minus 6s and minus 2s, our equation becomes a square s square minus 6s minus 2s plus 12 is equals to 0. Now, factorizing s square minus 6s and 2s plus 12s, it becomes s into s minus 6 minus 2 into s minus 6 is equals to 0. And since our brackets are the same, factorizing for that, it becomes s minus 6 in bracket s minus 2 is equals to 0. So therefore, s minus 6 will be equals to 0, or s minus 2 will be equals to 0. Simplifying for that, s will be either be equals to 6 or s will be equals to 2. Now, at the y-intercept, s is equals to 0. So substituting s equals to 0 in our equation, y will be equals to 8 in bracket 0 minus 0 in bracket square minus 12, which simplifies to minus 12. So our coordinates at our turning point is 4 and 4. At the s-intercept is 2 and 0, and also 6 and 0. And at the y-intercept, 0 and minus 12. Now, for the big part of our question, that is to get the line of symmetry. The line of symmetry is basically a vertical line that passes through the turning point. So it will be a line that passes through the turning point and cuts the s-axis. So since at the turning point s is equals to 4, so it will be a line that passes through the turning point and cuts it s at the point where s is equals to 4. Sketching, it becomes For the C part of our question, that is the area bounded by the curve, it will be the integral of our equation, that is 8s minus s squared minus 12s, with our upper limit being 6 and our lower limit being 2. And integrating, it will be equals to 8s squared over 2 minus s cubed over 3 minus 12s. Now substituting for upper and lower limit, it becomes or will be equals to 4 in bracket c squared minus c squared in bracket divided by 3 minus 12 in bracket 6 minus in bracket 4 in bracket 2 to the power of 2 minus 2 to the power of 3 divided by 3 minus 12 in bracket 2. And simplifying both parts, it will be equals to 144 minus 216 divided by 3 minus 72 minus in bracket 16 minus 8 over 3 minus 24, which should be equals to 0 minus in brackets minus 8 minus 8 over 3. And simplifying our bracket, it will be equals to 32 over 3 square units. Our next question is from November 1999. It states that calculate the area of the finite region bounded by the curve y is equals to s squared minus 7s plus 10 and the s axis. Now a question like this, our very first point of attention is to try and sketch out our curve. Now to do that, we are going to be needing three coordinates, that is the turning point, the s-intercept and the y-intercept. Now looking for our turning point, we are going to be writing down our equation y is equals to s squared minus 7s plus 10, and differentiating, the y over the s will be equals to 2s minus 7. We know that our turning point, the y over the s is equals to 0, so substituting the y over the s will be equals to 0, 2s minus 7 will be equals to 0 and 2s will be equals to 7. Dividing both sides by 2, s will be equals to 3 and half or 3.5. Now to get the value of y at the turning point, we are going to be substituting s equals to 3.5 in our equation, and doing so it becomes y is equals to 3.5 in bracket square minus 7 in bracket 3.5 plus 10, which will be equals to 12.25 minus 24.5 plus 10, and adding everything together it will be equals to minus 2.25. So therefore our coordinate at turning point will be equals to 3.5 and minus 2.25. Next, we are going to be determining whether it's at maximum or at minimum. This is to know the direction of our curve, and we know that at maximum or minimum, the square y over the s square when lesser than 0 is maximum and when greater than 0 is minimum. So differentiating 2s minus 7 further to get the square y over the s square, it will be equals to 2, and since 2 is greater than 0, it is a minimum point. Now the next step is to get our intercept. Now to get our s-intercept, y will be equals to 0, so substituting y equals to 0 in our equation, it becomes s squared minus 7s plus 10 is equals to 0. Now we are going to be solving the quadratic equation using factor method, and to do that we are going to be looking for two numbers in which when we multiply them it's going to give us 10, and when we add them together it's going to give us minus 7. Now the two number is minus 5 and minus 2, because minus 5 times minus 2 is 10 and minus 5 plus minus 2 is minus 7. So splitting minus 7 into, or minus 7s into minus 5s and minus 2s, it becomes s squared minus 5s minus 2s plus 10 is equals to 0. And factorizing, it becomes s in bracket s minus 5 minus 2 in bracket s minus 5 will be equals to 0. Since our brackets are the same, it becomes s minus 5 in bracket s minus 2 in bracket is equals to 0. So therefore s will be equals to 2 or s will be equals to 5. Now to get our y-intercept, s will be equal to 0. So doing same and substituting s equals to 0 in our equation, y will be equals to 0 square minus 7 in bracket 0 plus 10, which will make y to be equals to 10. So our different coordinates are at turning point 3.5 and minus 2.25 at s-intercept 2 and 0 and 5 and 0, and at y-intercept 0 and 10. So sketching using this coordinate, our sketch is going to be this. Now, since our shaded region or our bounded region is below the x-axis, the area bounded by the region will be equals to the negative of the integral of our function, taking our limit at both points on the x-axis. That is to be equals to the negative of the integral of s squared minus 7s plus 10 ds, with our upper limit being 5 and 2. So therefore, integrating the integral of s squared minus 7s plus 10 ds, our upper limit being 5 and 2, it will be equals to s cubed divided by 3 minus 7s squared divided by 2 plus 10s, with our upper limit being 5 and 2. Now, substituting for upper and lower limit, it will be equals to, in bracket, 5 cubed divided by 3 minus 7 in bracket 5 square divided by 2 plus 10 in bracket 5 minus, in bracket, 2 cubed divided by 3 minus 7 in bracket 2 square divided by 2 plus 10 in bracket 2. Now, simplifying our fractions further, it will be equals to, in bracket, 125 divided by 3 minus 175 divided by 2 plus 50 minus, in bracket, 8 divided by 3 minus 28 divided by 2 plus 20, which should be equals to, in bracket, 250 minus 525 plus 300 divided by 6 minus, in bracket, 16 minus 84 plus 120 divided by 6, which should be equals to 25 divided by 6 in bracket minus 52 divided by 6 in bracket. And simplifying further, it will be equals to minus 27 divided by 6, which when broken down will be equals to minus 9 over 2, which is also equals to minus 4.5. Now, our area of bounded region will now be equals to minus, in bracket, minus 4.5, which is equals to 4.5 square units. Our next question is from November 2000, and it states that calculate in square units the area of the finite region bounded by the curve y is equals to s squared plus 2s minus 3 and the s-axis, and we're given the options. Now, in our solution, the first thing we are going to find is to find our coordinates of our turning points, our s-intercept and our y-intercept, so that we can sketch our curve and hereby be able to evaluate the integral. Writing down our equation, y is equals to s squared plus 2s minus 3, and when we differentiate it, dy over the s will be equals to 2s plus 2. Now, our turning point, dy over the s is equals to 0. Now, substituting dy over the s will be equals to 0, 2s plus 2 will be equals to 0, and 2s will be equals to minus 2. Dividing both sides by 2, s will be equals to minus 1. Now, for the value of y at the turning point, we are going to be substituting s equals to minus 1 in our equation, and when we do that, it becomes y is equals to minus 1 in bracket square plus 2 in bracket minus 1 minus 3, which will be equals to 1 minus 2 minus 3, which is equals to minus 4. So at our turning point, our s value is minus 1 and our y value is minus 4. Next, we are going to determine whether it's at maximum or minimum, and to do that, we have to find the square y over the s square. And differentiating, the square y over the s square will be equals to 2, and since it is greater than 0, it's a minimum point. Now, the other 2 points we need are our intercepts. Now, for the s-intercept, y will be equals to 0. So substituting y equals to 0 in our equation, it becomes s squared plus 2s minus 3 is equals to 0. And solving the quadratic equation using factor method, we are going to be looking for two numbers which, when we multiply them, will give us minus 3, and when we add them, it's going to give us 2. Now, the numbers are plus 3 and minus 1. So splitting 2s into plus 3 and minus s, it becomes s squared plus 3s minus s minus 3 is equals to 0. And factorizing, it becomes s into s plus 3 minus 1 into s plus 3 is equals to 0. Factorizing further, it becomes s plus 3 in bracket s minus 1 is equal to 0. So therefore s plus 3 will be equal to 0, or s minus 1 will be equal to 0, which makes s to be equal to minus 3 or 1. Our next step is to find our y-intercept, and at our y-intercept s is equals to 0. So we're substituting s equals to 0 in our equation, and when we do that, it becomes y is equals to 0 squared plus 2 in bracket 0 minus 3, which should be minus 3. Now, having our different coordinates, we can now sketch our curve. At our turning point, our coordinate is minus 1 and minus 4. At the s-intercepts is minus 3 and 0, and 1 and 0, and at our y-intercept is 0 and minus 3. Now, using this coordinate to sketch, we are going to have a graph as shown on the screen. Final part of our question, the area of the bounded region. Since the bounded region is below the x-axis, it's going to be the negative of the integral of our function using our upper and lower limits gotten from the sketch. Now, doing so, the area of our bounded region will be equals to minus the integral of s squared plus 2s minus 3, with our upper limit being 1 and our lower limit being minus 3, and integrating, it becomes s cubed divided by 3 plus s squared minus 3s, our upper limit being 1 and our lower limit being minus 3. Now, substituting for upper and lower limit, it will be equals to, in bracket, 1 over 3 plus 1 minus 3 minus, in bracket, minus 3 raised to the power of 3 divided by 3 plus minus 3 in bracket square minus 3 in brackets minus 3, and simplifying our bracket, it will be equals to, on our left hand side, we will spare the fraction to be 1 plus 3 minus 9 divided by 3 in brackets minus, in bracket, minus 9 plus 9 plus 9, which is actually 9, which should be equals to minus 5 over 3 minus 9, and solving the fraction to be equals to minus 5 minus 27 divided by 3, which is equals to minus 32 divided by 3. Now, remembering, the area of our bounded region is the negative of our integral, which is the negative of the integral of s squared plus 2s minus 3 ds, to our upper limit being 1 and minus 3. So therefore, it will be equals to the negative of minus 32 over 3, which is equals to 32 over 3 square units. Our next question states that A. Sketch the curve y equals to s plus 2 in bracket, s minus 2 in bracket, and s minus 4 in bracket. B. Find the maximum and the minimum value of the function to the nearest whole number. And C. Calculate the area enclosed by the curve and the axis. Now, first, we will need to expand our brackets to know our function proper. So, expanding s squared in bracket, s minus 2 in bracket, and s minus 4 in bracket, it will be equals to s minus 4 in bracket, s plus 2 in bracket, s minus 2. That's why we are going to be expanding s plus 2 and s minus 2 first. And doing so, it will be equals to s minus 4 in bracket, then s squared minus 2s plus 2s minus 4 in bracket. That is when we expand s plus 2 in bracket, s minus 2 in bracket. It's going to give us s squared minus 2s plus 2s minus 4, which should be equals to s minus 4 in bracket, s squared minus 4 in bracket. So expanding further, it will be equals to s into s squared minus 4 and minus 4 into s squared minus 4, which should bring y to be equals to s cubed minus 4s squared minus 4s plus 16. So we've gotten our function to be equals to s cubed minus 4s squared minus 4s plus 15. Next, we know that at maximum or minimum, the y over the s will be equals to 0. So differentiating our function, the y over the s will now be equals to 3s squared minus 8s minus 4. And since the y over the s is also equals to 0, this will be equals to 0. Now, solving 3s squared minus 8s minus 4 equals to 0 using quadratic formula, s will be equals to minus, in bracket, minus 8 plus or minus the square root of minus 8 in bracket square minus 4 times 3 times, in bracket, minus 4 divided by 2 times 3, which will be equals to 8 plus or minus the square root of 412 divided by 6, which will be equals to 3.1 or minus 0.4. Now we are going to, since we have two value of s, we are going to be determining which of the turning point is maximum or minimum. And to do that, we need to find the value of the square y over the s square, and differentiating the square y over the s square is equals to 6s minus 8. So when s is equals to 3.1, the square y over the s square will be equals to 6 into 3.1 minus 8, which is equals to 10.6. And since it is greater than 0, this will be our minimum point. And when s equals to minus 0.4, 6s minus 8 will be equals to this in bracket minus 0.4 minus 8, which is equals to minus 10.4. And since this is lesser than 0, is going to be our maximum point. So therefore we've gotten the value for our maximum and minimum point. Next, we'll be looking for our intercept. And first, for our intercept at the s-axis, y will be equals to 0. So substituting y to be equals to 0, 0 will be equals to s plus 2 in bracket, s minus 2 in bracket, and s minus 4 in bracket, which means that s plus 2 will be equals to 0, or s minus 2 will be equals to 0, or s minus 4 will be equals to 0. Simplifying, s will be equals to minus 2, or s will be equals to 2, or s will be equals to 4. Now at our y-intercept, s is equals to 0. Now substituting s equals to 0 in our equation, y will be equals to s plus 2 in bracket, s minus 2 in bracket, s minus 4, which makes y to be equals to, in bracket 0 plus 2, in bracket 0 minus 2, in bracket 0 minus 4. So therefore y will be equals to 2 times minus 2 times minus 4, which is equals to 16. So having gotten all our points, let's bring everything together. Our coordinates at our turning point, our s value was 3.1 and our y value was 10.4 for our first point, and for our second point it was minus 0.4 and minus 10.4. For our s intercept, it was minus 2 and 0 for our first point, 2 and 0 for our second point, and 4 and 0 for our third point. And for our y intercept, it was 16 and 0. So using this point to sketch, we are going to be having a figure as shown in the screen. Now for the b part of our question, which is the maximum and the minimum value of our function. At maximum, s is equals to minus 0.4, and at minimum, s is equals to 3.1. So first of all, let's look for the maximum. That is when s is equals to minus 0.4. When s is equals to minus 0.4, y will be equals to minus 0.4 in bracket e to the power of 3 minus 4 in bracket minus 0.4 square minus 4 in bracket minus 0.4 plus 16, which will break down to y equals to minus 0.064 plus 0.64 plus 1.6 plus 16, which will also break down to y equals to 17.6 minus 0.704, and y will be equal to 16.896, approximately 17. Now for the minimum value of our function, s equals to 3.1 and minimum, and substituting into our function, y will be equals to 3.1 in bracket e to the power of 3 minus 4 in bracket 3.1 square minus 4 in bracket 3.1 plus 16, which will break down to y equals to 29.791 minus 38.44 minus 12.4 plus 16. Simplifying further, y will be equals to 45.791 minus 50.84, and y will be equals to minus 5.049, approximately 5. Now for the final part of our question, which is the area enclosed by the curve and the s-axis. As you can see from our sketch, there is two regions enclosed by the curve and the s-axis. Now for the one above the s-axis is going to be a positive integral, and for the one below the s-axis is going to be a negative integral. For the one above the s-axis, our limits are 2 and minus 2, and for the one below the s-axis, our limits are 4 and 2. So writing everything out, it will be equals to the integral of s cubed minus 4s squared minus 4s plus 16, with our upper limit being 2 and minus 2, plus the negative of the integral of s cubed minus 4s squared minus 4s plus 16, with our upper limit being 4 and 2. So we are going to be doing both of the integrals singly, then adding everything together. So integrating s cubed minus 4s squared minus 4s plus 16 with our upper limit being 2 and minus 4 to be equals to s to the power of 4 divided by 4 minus 4s cubed divided by 3 minus 2s squared plus 16s. Now substituting our upper and lower limit, it will become in bracket 2 raised to the power of 4 divided by 4 minus 4 in bracket 2 raised to the power of 3 divided by 3 minus 2 in bracket 2 raised to the power of 2 plus 16 in bracket 2 minus in bracket minus 2 to the power of 4 divided by 4 minus 4 in bracket minus 2 to the power of 3 divided by 3 minus 2 in bracket minus 2 square plus 16 in bracket minus 2. Now simplifying both brackets, it becomes 2 minus 32 divided by 3 minus 8 plus 32 in bracket minus in bracket 4 plus 32 divided by 3 minus 8 minus 32. Simplifying both fractions in both brackets, it becomes 12 minus 32 minus 24 plus 96 divided by 3 minus in bracket 12 plus 32 minus 24 minus 96 divided by 3. Both brackets simplify to 52 divided by 3 in bracket minus 76 divided by 3. The minus will multiply itself to become positive, so it will be equal to 52 divided by 3 plus 76 divided by 3, which is equals to 128 divided by 3. Now integrating s cubed minus 4s squared minus 4s plus 6, our upper limit being 4 and 2, also it will be equals to s to the power of 4 divided by 4 minus 4s cubed divided by 3 minus 2s squared plus 16s. Now substituting our upper and lower limit, it becomes in bracket 4 to the power of 4 divided by 4 minus 4 in bracket 4 to the power of 3 divided by 3 minus 2 in bracket 4 to the power of 2 plus 16 in bracket 4 minus in bracket 2 to the power of 4 divided by 4 minus 4 in bracket 2 to the power of 3 divided by 3 minus 2 in bracket 2 square plus 16 in bracket 2. Now simplifying both brackets, it becomes 64 minus 256 divided by 3 minus 32 plus 24 in bracket minus 4 minus 32 divided by 3 minus 8 plus 12 in brackets. Now solving both brackets, that's simplifying both fraction, it becomes 192 minus 256 minus 96 plus 72 divided by 3 in bracket minus in bracket 12 minus 32 minus 24 plus 36 divided by 3. Adding both bracket and simplifying both bracket, it becomes minus 88 divided by 3 minus in bracket minus 8 divided by 3, which should be equals to minus 88 divided by 3 plus 8 divided by 3. Adding the fraction to be equals to minus 80 divided by 3. So substituting both value for both of our integral we found, it will be equals to 128 divided by 3 plus in bracket minus in bracket minus 80 divided by 3, which should be equals to 128 divided by 3 plus 80 divided by 3, which is 208 divided by 3. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copy at bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.